Hello, STEM friends. It's October, so you know what that means? Spooky STEM time! Woo-hoo-hoo-hoo!
Oh my gosh. Frozen bubbles?
Hey! Hello, STEM friends. What I have for you today is so cool. It's so cool, in fact, it burns. What am I talking about here? I have in this cooler a very special kind of ice. Ooh, you hear that? Ice is a solid. That means the molecules are so cold, they're squished down together. I'm gonna add some heat, and heat is energy, and energy is gonna make them move and spread out and spread out. Except this ice is not going to melt. It can't melt because it's not water. This is frozen carbon dioxide, and it does this magic trick where it doesn't go from a solid to a liquid.
Water that has been frozen and then heated speeds up the molecules from a solid into a liquid into a gas. But dry ice, which is made of frozen carbon dioxide, is different.
It skips the liquid phase and goes from a solid into a gas. That's why they call it dry ice. Here we go. This is hot water. Look at the heat reacting with the frozen carbon dioxide. It's got a lot of energy, the heat does. This and many other tricks I'm going to show you today are very safe if you abide by a couple of rules. Number one, you have to be with an adult. I actually had to show my ID to get this dry ice. It's available at Publix, which is right down the street from Baker. It's the one on Giles and Baker. And it's like $1.50 a pound. So it's very inexpensive, but you definitely do need an adult for two main reasons. Number one, as I mentioned, it's so cold it'll burn your skin. Number two, it sublimates so quickly that energy that is escaping could cause an explosion, a very dangerous explosion. So we're gonna do some safe experiments today, and then you guys can try these at home with an adult. All right, I've got my assistant Finn here, and he is going to, with a glove on, pick up one of these pieces of ice. Now I told you earlier how the carbon dioxide is squished together. Well, now the heat from our surroundings is going to help that ice to get warmer and warmer with more energy and expand. To prove that, we're going to drop one of these pieces of ice and we're going to put it inside a balloon. Let's go and do two in there. Now, with virus season, we can't blow balloons up because of spreading the virus. Good news, you don't even have to. Just put some dry ice in there, tie in the knot, and what do you think is going to happen as that frozen carbon dioxide, dry ice, gets warmer and warmer? We're going to have to find out. So the balloon's taking a little while. I notice when I shake it, it does get a little warmer. We're going to let this sit and do its thing and move on to our next trick. If you have a container, you must be very careful. It is illegal to put dry ice in a closed container because eventually it will explode, and that is very dangerous. So what I have here is an old tennis ball container, and I have poked a hole in it with a straw so I could drop the dry ice down in it, get into the warm water, and it does its cool thing, sublimation. If I put a straw with the lid on the top, ooh, it turns into a geyser. And it just looks cooler. That's pretty fun. Notice it's not locked on here. I can lift it off. There's always an escape. So carbon dioxide is not poison, so it's safe for you to feel. How's it feel?
Weird.
Because it's cold?
O2 is the oxygen we breathe in. CO2 is the carbon dioxide we breathe out. Oxygen we breathe in, carbon dioxide we breathe out.
Well, to me it feels like that.
So the carbon dioxide is not dangerous in the sense it's not poisonous, but we need to breathe oxygen. And so the carbon dioxide actually pushes oxygen out of the way. So you don't want to breathe in too much of it because you won't get the oxygen that you need. So fire, like us, needs oxygen to breathe. And we now have a glass of carbon dioxide trapped in here. And it's heavier than regular air, so it sits down in the cup. We're going to pour it over the fire. What do you think is going to happen? Boom, there it goes.
Fire!
So the carbon dioxide pushed the oxygen out of the way, fire goes out. So it turns out many fire extinguishers are actually filled with carbon dioxide. Not because it's cold, not because it's wet, because it's not. The carbon dioxide takes the place of the oxygen, pushes the oxygen out of the way, and puts out the fire. The next experiment involves pressure. And anytime you're working with pressure, you need to protect your eyes. So what I have here is an old-fashioned film canister.
Taking pictures 20 years ago, you had to buy a roll of film, open the camera, put the film inside the camera, take your 24 pictures, take the film back out of the camera, then put the roll of film into a canister to protect it, and then take the film to a local film developer who prints it out into pictures. You've seen one of these in the 1980s movie Back to the Future.
And the top pops off quite easily. So I'm not putting the dry ice in a closed container with the lid that's screwed on tight. It's just a top that goes on and top that pops off. And what do you think is going to happen? You see that it's sublimating. You see that the gas is coming off the top there. What's going to happen?
I'm scared.
What's your prediction? You definitely do not want your face over the top of it. So that cold dry ice is getting warmed by the air around us and the air inside the canister. And those molecules are feeling the heat, and the heat is energy, and the energy is making them move around and move around and move around. Faster, faster, faster. Woo-hoo-hoo! Science! Woo-hoo-hoo! All right, for this next trick, I'm going to use a quarter, which is room temperature. This quarter is about 70 degrees, the same as the outside, and I'm going to put it on the dry ice, which is minus 100 degrees Fahrenheit. Big difference. The heat from the quarter is going to go into the dry ice, and something really funny is going to happen. Watch this. What's happening?
Vibrating.
That's the heat.
It's shivering.
It's shivering.
Shivering 'cause it's cold.
Okay, we discovered the quarter cools off really quickly, so you gotta do this fast. Warm quarter, room temperature.
It's breaking.
Whoa!
Sounds like it's cracking.
Sounds like we're torturing the quarter. Sorry, quarter.
It's shivering. Crazy. Oh, at the edges, you can see as it like starts. Yeah, it looks like there's frost appearing on the edges because it's so cold. Look, there's
It's
snow.
the energy of the heat in the quarter reacting with the cold of the dry ice. All right, new trick. This time, metal spoon on the dry ice. What do you think's gonna happen? All right,
Oh no.
what do you expect to happen here?
Oh no.
All right, ready? Shh.
Oh my god!
It's crying.
Oh, poor thing.
Okay, for this next trick, it's called boo bubbles. So what we're gonna do is you pour some warm water into the bowl.
That's a lot
That's
of
good.
warm water.
What we're gonna do is take some cloth. This is from the sink, the kind of thing we use to wash dishes. Or you could also use cotton string. I'm gonna just soak this in some soapy water, dish soap and water mixture there. And I'm gonna drag this across the top. Here we go, here we go, here we go. Here we go. Here we go.
Oh no,
Is it working?
Yeah.
There we go.
That's amazing. What happens if you try to pop it?
Good question. Let's see what happens. Okay, so what's happening?
It's getting bigger. It's
the gases that are trapped in the dry ice are getting warmer and warmer, and they're expanding.
Oh, no, no.
All right, let's try it again.
Let's do it. Hopefully it works this time. Does it work? Yeah. It's working.
Yes.
Yay! This is super cool.
Okay.
Can we do it again? It's a bubble. Made a bubble. Made it. Nice. It's drifting over. Oh no.
That's a good one.
It's a witch's
There are like a bunch of little. Like,
Now I just
bubbles
need a
in it.
prince to turn into a frog.
Oh my gosh, it's working!
I
Oh my
just
gosh, wait. It's working anyways.
Oh my gosh! Take it,
Uncle Matt!
Ooh, how'd you
There
do
are a
that?
bunch of tiny. We didn't even do anything.
I'm
There
a
were a bunch
witch.
of like.
I'm
All of
a
the bubbles
witch.
just. There are a bunch of tiny like bubbles appearing, and they
wow.
just started merging together. into
By
one big
itself?
bubble.
That's awesome.
Yeah.
Ben's turn.
And then my turn after.
Whoa!
For our
it's
next
my turn
trick,
next.
I'm just
I've
gonna
been
put a
waiting.
bunch of soap down in there.
Okay.
Now,
But I
you
want
can
to pop.
pick them up.
What? Can I
And then pop them with your thumb.
oh my
Pew, pew, pew.
Funner is a funner word. Correct.
Ocean. There we go. For this next trick, got an old recycled bucket of cheese balls here. I just cut a hole in it and hot glued an old fish tank tube to it. And I hot glued it to this plastic piece from a kid's old toy, and the hot glue came undone, and so we're gonna try duct tape this time. Now, we've got our geyser with a kind of a large, a little bit bigger than a $50 coin size opening here. And I'm going to dip this down in some soapy water. There we go. So bubbles get popped by the oil on our hands, but the towel doesn't have the oil. And look at that.
Wow.
So I've added some more soap to our bubble mix here. Woo. See if I can get one to rest on it. Yeah, look at that.
There we go.
So I've got my mini geyser here with the straw, and I'm just gonna see if I can make some mini boo bubbles. Oh yeah. That's cool. It takes a little bit, it's interesting. It's like it brings the soap in and then pushes it back out. So you can totally do this at home. And what do you think is gonna happen if I pour soap directly into it? Well, let's find out. It's like a boa constrictor climbing out of a magic trick. Quick tips about dry ice. It is always sublimating. You can't see it, but it is constantly rising up and out. So make sure that you put it in a cooler that is going to allow that gas to escape, because otherwise it's going to explode. Also, don't put it in your freezer. It's tempting to want to put the cold stuff in the freezer. This is so cold it will trick your freezer into turning off, and that's not good for the stuff in the freezer. Also, don't put this in the same room where you sleep, because again, that gas is coming out, and the carbon dioxide gas is not dangerous, but it pushes away the oxygen, which that's dangerous. So you don't want to sleep with this, and you also don't want to drive in a car with the windows up with this for too long. It does sublimate about a pound every 4 hours. So if you get it the night before, the next day it's going to be gone. That's just something you need to know. So it doesn't last very long, but it's super fun. Just be careful, be safe.